how to convert decimal to binary, binary to decimal, then numbers are means how in one's complement what is the range, in two's complement what is the range, and then we are going to see what this thing, base of the number, concept of overflow. This is very important.
So
Yes, tell me.
I have a doubt, sir.
Yes, tell
So
me.
I have getting a problem in understanding that when we have to use r minus one's complement and when we have to
Pardon?
use.
I couldn't hear you. I couldn't get you.
Sir, I
Repeat.
said when we have to use r minus one's complement and when
Hmm.
we have to use that r's complement. If it's used like if he gave a number and then he asked to find the complement of that number, like
It
if he
will
asked.
be given. It will be given to find like either two's complement or one's complement, or if they have said like suppose for example uh, it is given a number is 1 2 3 4 and it is said find four's complement. Okay, four's complement when base is 5. Okay, base is 5. So in 5 you are going to have what, you are going to have numbers from 0 to 4. So you need to find four's complement when the base is 5. So it is what, 4 4 4 4 1 2 3 4. So subtract this, this will be 0 1 2 3. So this is what, this is your four's complement when your base is 5. Now if you want to find 5's complement of the same number, so 5's complement will be what? You need to add plus 1 to it. So this will be 3 2 1 1. So always this base is going to be specified, and this means if this is r minus 1's complement you need to find, or if you need to find r's complement, it will be specified to you in the question. Others did not know about the class today or what?
So it
So
was
I
posted in the group that we have a class today.
Yes, actually, I saw that Dinesh sir posted. That is why I didn't post actually.
It's also on the schedule, sir. Like we have a BLD classes.
Yes, Dinesh sir forwarded also.
Yeah.
Okay, so it's okay. Piyush even okay. You so have message, so it's okay. Okay, so others will join eventually. It's okay. So let us start with the simple topic today. So let us finish this chapter today, okay? Because it's like 1 month, and now I am going to push you guys a little bit, okay? Because due to my health, there were like means we couldn't give time to all the sessions, okay? And even we are going slow. So by the end of this month, we need to be in a good position. Chalo. So what is decimal to binary and binary to decimal? We are studying this like from very second sem or third sem. Okay. So suppose we have a decimal number like 21. So how
So,
do we find the binary? Yes, tell me.
so you did say that what was the problems with one's complement? We have to discuss it.
What was the problem with one's complement where?
Yes. That was the heading you said us to put like the problem in one's complement.
Pardon? What did I say exactly?
You said that we'll start from the problems in one's complement and you ask us to put the heading.
Okay. So yes, I told you what are the problems in one's complement for which we actually use two's complement. Okay. So look very carefully. So where was I discussing one's complement, addition, subtraction? So this was one's complement. Okay. This is what happens actually if you jump in the class after very long time. So okay, let it be. I will explain it from here. So if you guys remember one's complement, in one's complement, basically when we were doing all the calculation, so when we performed the arithmetic, if carry was generated, okay, if carry was generated, What I told you, that the number will be positive and the carry generated, it was added to the LSB of result. Okay, and if carry was not generated, this implies that the number is negative, and if I want to get the original number, so for original number, what we needed to do? We needed to do 1's complement of the given number that we have. So now, in 1's complement, basically the problem is this. When carry is generated, so we need to add it to the LSB of the result. Now, in all the computers and all the digital circuit, for addition of this extra bit, we require certain amount of hardware. Okay, we require certain amount of hardware. So that is why basically we avoid 1's complement. We usually take 2's complement. Why? Because in 2's complement, if carry is generated, we discard the carry. Okay, we discard the carry in 2's complement, and we say that if carry is generated, it is a positive number. If it is a negative number, then for getting the original number, we need to take the 2's complement of the given number, or the number that we are getting after addition of two numbers. Okay, so the main problem is this: with 1's complement, whenever a carry is generated, we need to add it to the result. So that is why usually we don't use 1's complement. Is that clear? Means I have even shown you somewhere over here. Okay, problem in 1's complement mostly use 2. Okay, over here I have written. So carry out generated, carry out added to LSB, no C out generated, negative. Okay, no carry generated. So here I might have done somewhere that I have added the carry. If you guys, means I am not able to recall where I have done that, but actually I have done. Can you look that in your notebook? Can you look that? Have I done that thing? Tell me. Anyone? Have I discussed this point or not?
No,
This
sir,
one?
No, sir, you're discussing it now.
I haven't showed you an example of this.
So I didn't wrote it. No, sir,
No,
I don't think.
it can't happen that I haven't discussed. So
Piyush
where?
was saying it, so I guess I left the point.
No, wait. Piyush is saying it was done. So Shubham, why you didn't do it? So I might have discussed, because here I am not able to. Okay, chalo. Once again I will show it to you guys. Suppose what we do, minus 21 plus 9 was the example. Okay, so this was 1's complement. Okay, carry out generated. So where, means why I haven't carry out generated? Okay, so I haven't added this. Okay, chalo, once again I will do this. It's okay. So let us once again take this 21 plus 9. Means yes, minus, I also remember I have taken this example. So Shubham, means why haven't you not noted this?
Sir, I've noted this. That was the
You
last
have
example.
yes. So then there I have discussed that whenever in 1's complement carry is generated, you have to add the carry to the result. Whereas in 2's complement we discard the carry. Okay, we discard the carry. So yes, that was actually done. So chalo, let us move on. Yes. So in total there were 4 examples. I have solved minus 21 plus 9 using 1's complement as well as using 2's complement, and then I have solved 21 minus 9 using 1's complement as well as 2's complement. So there are in total 4 examples. Okay, 4 examples I have solved. And even if you are not able to get this, then you can do one thing. Today you go home, means you are at home only. So today after class you can do what? You can just revise it and let me know if you are not getting. Okay, so let us not waste time. So let us see how to convert decimal to binary and binary to decimal. So this is very simple thing. Suppose for example 21, if you need to convert this in your binary, so simple, if you can do it like this, 16 plus 4 plus 1, then it is very simple, 2 to the power 4, 2 square, 2 to the power 0, and you can write it like 10101. But for long numbers like 312, okay, for big numbers you cannot write it like this. Okay, so even here you can write it like 256 plus 64. So this will be what? This will be 320. No, you cannot have this. So 256 plus 32. So this will be 288 plus 16. So 288 plus 16, even I am not able to do mental calculations today. So let me show you how to do this. So we use what? Double method. So that is basically what? Repeatedly divided by 2. Okay, repeatedly divided by 2. So if I divide this, so this will be 156, remainder is what? 0. So divide it again by 2. So this will be 78, again 0. Again divided by 2. So 39, 19, 1. So 2 nines are 18, 1. 2, 4, 1. 2 twos are 4. Remainder is 0. And 2 divided by 1 means 2 divided by 2 is 1. Remainder is 0. So now if you want to write, so this point will be your MSB and this point will be your LSB. Okay, this is MSB, this is your LSB. If you want to write the number, so this will be 10011100. So this is your 312. Okay, 312. And if you want to convert this once again from, suppose this is a binary number given to you, you want to convert it to decimal. So what are you going to do? You need to basically put the powers of 2. Okay, so 2 to the power 8 plus 2 to the power 5 plus 2 to the power 4 and 2 to the power 3. So this, if you solve, so this will be what? So this will be 256 plus 32 plus 16 plus 8. So I was correct, just I couldn't add 8 in the last. Okay, so this you will get it to be 312. So today I was means I was feeling good. So what you have written? Okay, 21 minus 9. So I was watching something and I was reading. So I came across certain things, like if you want to multiply certain numbers, okay, so binary numbers, it came to us like in your what, I guess around in 1800 it came. But suppose you want to multiply this two number, okay, you want to multiply this two number. So what you do, you divide this number by 2 repeatedly. So look what happens. So this is not in our GATE syllabus. Means I was studying something fascinating, so I wanted to share it with you guys. So if you divide this, this will be 9. Again divided by 2. So that will be what? 4. Remainder is what? It is like 1. So leave that. Again divided by 2. So this will be 2. Again divided by 2. So this will be 1. Okay, and double this one, double this, so this will be 46 and this will be 92, this will be what, 92, 184 and 368. Okay, so basically what I did, I divided this left hand side by 2 and multiplied this right hand side with 2. Now remove all the numbers basically that are what, that are odd. So this is odd number, this is odd number. Now add all this, add all this. So basically I am asking you to add 23, 92, 184. So if you do this, this is what, 3 plus 4, 7, 9, 9, 8, 17, 19, 1. So this is 299. So I am not getting the correct thing. 8 3s are 24. I don't know. So where I have made mistake. So 23, 92, 184, 6, 9. So maybe I have done some mistake. 46, 86, 92, 184, 368. Okay. So this is 9. I might have done some mistake. Okay. So I was learning actually this thing. This was very fascinating to me and I just did. So I was getting the answer. Now I am not getting. So means that trick was very cool, means people have used actually this binary logic only, but I am not able to get. Okay, let me do it once again. I did it. So let me take 1823. So if I divide it by 2, so this is 9. Once again, if I divide by 2, so that will be 4, 2 and 1. And this will be 46. So 92, 184 and this will be 368. This goes. I need to add 23, 92 and 184. Just let me get it correct. 9, 19 and 1, 299. So this, what is the answer? We get 18 into 23. That is not this, I guess. 299 we don't get. So that is 414. I don't know why I am not getting. Means I was actually fascinated by this, but I am not getting. Okay, so I will share this method with you later on. Okay, so I have also learned this thing. So I was learning Vedic maths. So this was mentioned in Vedic maths. Okay, so in Vedas time also people were using binary. So I learned this, but I am not getting the answer. Okay, so only today I was feeling good, so I was watching the videos of this Vedic maths, but I guess I am making some mistake because I am also learning. So I guess I am making some mistake. It's okay. So I will share this means method in the next class. Okay. So why I am not getting the correct last time? Let me try. So 9. So if I divide it by 2, so 4. This will be 2. This will be 1. 46. This will be 92. This will be 184 and this will be 368. So all the odd numbers, sorry, so all the even numbers do we need to cancel or what? 46 and 368. So yes, so 404 means that was the answer. Sorry. So let me explain. Wait a second. Yes. So I made a mistake. Rather than cancelling the odd numbers, you need to cancel the even numbers. Okay, you need to cancel the even numbers. So sorry, 414 is the answer. Yes, I know 414 is the answer. So rather than cancelling the odd numbers, you need to cancel the even numbers. Okay, so cancel all the even numbers. So this is also cancel this one. This is also even. This is also even. And add this. Okay. Add this whatever number is remaining. So that is 368 and 46. So 8, 6, 14, 1. So this is 1. This is 1. So 414. So basically what we are doing what? We are multiplying this two number 18 and 23 binary. Okay, so basically what we are doing, we are multiplying the numbers in binary. So even I had learned this concept, so I was feeling very good. Means Vedic mathematics, it's like in what, 3 or 4 BC. Okay, at that time they guys didn't know about binary numbers, but yet they could solve like this. Now we are not accustomed to solving like this, or else we could have done it very easily. Okay, So such kind of things already existed. Only thing is that we never knew. Okay, like Newton, he was sitting under a tree, an apple fell on his head. It was not the first time that people saw one apple falling from tree. Okay, it was not the first time, but Newton was the first guy who thought about it. That why is apple falling from tree? Why doesn't it go up? Okay, so everything exists in nature. Only thing is that we need to have observation skills to observe that. So this mathematics, such kind of mathematics, it's usually existed, but now we are knowing that there is something known as binary numbers or decimal numbers. Okay, so okay, this was for your whole number. Now suppose if I have a fraction number, so how to convert it to binary? Simple, just multiply it with 2. So this will be what? 0 300. So again bring this number for multiplication. So this will be 0 600. Again bring this one for 2, means multiply it with 2. So this will be 1.20. Again multiply this 200 by 2, 0.200 by 2. So this will be 0.400. Now again multiply this with 2, and this will keep on going. Okay, so this will be 0.80. Now once again you can do this, keep on doing this. So you will be getting 1.600, and you can keep on doing this till you get 1.000, because when you get this, then you cannot multiply it. So no need to do, you can do it up to like 3 or 4. And here when you want to write the number 0.150 in binary, so this is in decimal, if you want to write it in binary, so this point will be your MSB and this last will be your LSB. Okay, so here if you write, so this will be 0010001, and this will keep on going whenever it will terminate. Okay, so any doubts in this, how to convert numbers? So this is very simple. Okay, decimal to binary, binary to decimal, we all know this. There is nothing over here to understand. Okay, now over here, suppose, so what I wanted to show over here, 2110 minus 2110. Okay, yes. So here actually I wanted to show you this, that 21 and minus 21 is equal to 0. So when we were discussing actually sign magnitude representation, I told you one thing, if you remember, that for positive number, sign magnitude representation is same as your 1's complement. It is same as your 2's complement. Whereas in negative numbers, for sign magnitude representation, we need to take first 1's complement and then we need to take 2's complement. Okay. And if I have a normal number, suppose if I have 21, I told you this is one normal number. Don't confuse yourself. Okay. Listen very carefully, then you can note down. I am saying 21 is a normal number. I just want to know what will be its 2's complement. I haven't told you that whether this is in sign magnitude representation or not. I just told you 21 is a normal number. Just represent it in 2's complement. So what you are going to do? First you are going to write the binary equivalent of 21. Then you are going to calculate what? 1's complement. So that will be 0, 1, 0, 1, 0. Now for 2's complement, what you are going to do? You are going to add 1 to this. So this will be 0, 1, 0, 1, 1. So you can see this 21, this is a normal number and for this 2's complement is this. Now if it is your positive, I tell you that 21, represent it in sign magnitude representation. So you know what, this is plus 21, so you are going to write it like this: 0 0 1 0 1 0 1, where this 0 is what, this is your sign bit and these are your magnitude bit. Okay, here I didn't tell you that this is actually what, this is not your, means not represented in sign form. So here you can see this number in 2's complement is looking something like this, but in your sign magnitude representation plus 21 it looks like this. And if you want to represent minus 21 in sign magnitude representation, so that will be 1 1 0 1 0 1. In 1's complement it will be what, it will be 1, and this will be 0 1 0 1 0. In 2's complement it will be what, minus 21, I am telling. So this will be 1, and to this I need to add 1. So that will be what, 0 1 0 1 1. Okay, so there is a difference in these three things. This is a normal number without any sign magnitude representation. These two are represented in sign magnitude representation. Now can you tell me why have I, means in positive, in sign magnitude representation, why the representation of positive number is same as your sign magnitude representation in 2's complement? You can see all the three are same. Can you tell me? Already I have told you guys. What? Array, if we are using sign magnitude representation, means in 2's complement or even in 1's complement, I told you what initially, that in sign magnitude representation the problem was that whenever we add a same positive and negative number, we were not getting 0. We were not getting 0. So this already I have explained. So where did I start sign magnitude representation?
So it was not done back.
So where is it?
So the forward slides. Yeah, yes. Here somewhere.
Yes, over here. Okay. So over here we were not getting what? We were not getting 0. But whereas in your 1's complement and 2's complement, whenever we did a same number, means a same positive and negative number, we were getting 0. And even you can solve it over here. 1 plus 1 0, carry will be 1. So this will be again 0, carry is 1. Again if you do this, 0, carry will be 1. Again if you do this, so this will be 0, carry will be 1. Again if you do this, so 0, carry will be 1. So now again if you do this, 0, carry will be 1. So carry generated means what? Positive number, and usually in 2's complement we neglect it. So even you can add two numbers in 1's complement. Okay, you can add two numbers in 1's complement and you will get the same thing. Now one more thing I had written over here, if you see, problem in 1's complement, that we mostly use 2's complement. So one of the reason I told you, okay, one of the reason I told you that usually we have a carry. Due to that, what we do, we need to add it to your result to get the number. So that is one problem. One more problem we have that we are going to see now. Okay, So what is this? The number is represented in sign magnitude representation in 2's complement. Find the original number. Solve this question. Solve this question. So tell me quickly what will be the answer for this question. And after that, I am going to show one more problem of 1's complement due to which we use 2's complement. So very quickly tell me what will be the number in decimal. See here, the number is represented in sign magnitude representation. This is not normal 2's complement. Okay. This is represented in sign magnitude representation. So that means what? If it is represented in sign magnitude representation, so first bit is your sign bit. So sign bit, you can see 1, that means this is negative number. So for getting the original number, we need to take what? We need to take 2's complement once again. So if I want to find 2's complement, so have I told you the shortcut for finding 2's complement? Have I told you the shortcut for finding 2's complement? Tell me yes or no at least, means I am not able to recall. Have I told you yes, no?
No, sir.
No. Okay, fine. So look over here. So this is sign bit. And I told you in your sign magnitude representation, never ever disturb this sign bit. So this is what? This is your magnitude bit. Now if I want to find 2's complement, start from your rightmost bit and go to the position where you encounter the first one. Okay, so copy up to that bit, so 0, 1, and the remaining after this one, means the first time where you encounter 1, after that what you need to do, you need to interchange all the bit or complement all the bit. So this will be 1, 0, 1, and this is sign bit. So sign bit, don't do anything. Now over here, this is actually directly the 2's complement. Now if you don't agree, calculate from here. So if you want to calculate 2's complement, first take 1's complement. So that will be 1, 0, 1, 0, 1. To this add 1. So if you add 1, this will be 0. This will be 1. And this will be 1. This will be 0, 1, 1. So you can see you are getting the same result that you got over here. Okay. The same result that you got over here. Okay. So this is one shortcut trick for finding. You search for the first one from your rightmost bit, and when you get the first one, copy up to that bit, and the remaining bit you need to do what? You need to complement. So this is your 2's complement. So what is this number? You can see this is 0, 1, 2, 3, 4. What? Any doubts?
No, sir.
Yes. So this is what? 16 plus 2, 16 plus 4 plus 2. So that is 22. So the real, means original number is what? Minus 22. Any doubts? Any doubt, anyone? Okay, fine. Now, this is one question, that this number are represented, some of the numbers are given in 1's complement sign magnitude representation. Okay, so these are sign magnitude representation. Find the original number. Very quickly I want you to find what will be the original number. So these number are in 1's complement. Sign magnitude representation in 1's complement. I want you to tell me what will be the original number. So very quickly tell me. See here. So this is what? As this is your sign magnitude representation, this is your sign bit. So 0 corresponds, means this 4 number corresponds to positive number. So this will be 0, means plus 0, plus 1, plus 2, plus 3. What about this one? From here to here, this is your negative number. And if this is your negative number, you need to take 1's complement once again. So this will be 1 1 1. So this will be what? I am directly writing over here -3, -2, -1 and -0. Okay, so one's complement if you take once again, that will be 1 1 1. Over here if you take, so that will be 1 1 0. Over here if you take 1 0 1, and over here if you take, so this will be 1 0 0. Okay, so this corresponds to what? 0 0 corresponds to 0, and this is your sign bit, so that is why -0. Tell me any doubts? Any doubt in this? So you can see, yes, tell me.
So how +0 and -0 are different? And
Using
why?
the representation. So I will tell actually. I will tell you. Okay. So
Yeah.
just listen at the moment. So here you can see that using 3 bits, the range of number that I got in one's complement, it is from where to where? It is from -3 to +3. Okay, from -3 to +3. Now if I take 4 bit, okay, if I take 4 bits, so the range of number that I can represent, it will be from -7 to +7, because numbers will be what? 0 0 0, 0 0 0 1, like this till 1 1 1 1. So if you take, this will be +0, and if you take over here, this will be -0, and in between you will get from, means over here you will get 0 1 1 1, and first term will be 1 0 0 0. So this will correspond to +7, and this number will correspond to -7. So from -7 to +7 in 4 bit. Now if I generalize it to n bit, so for n bit, the range of numbers that I can represent using one's complement sign magnitude representation, it is -2 to the power n minus 1 2 plus 2 to the power n minus 1 -1. Okay, is this clear? Now you can see one thing, that 0 has 2 representation in one's complement. Now this is also problematic, because what we know, there is no concept of +0 and -0 in normal arithmetic. Yes, in limit we have +0 and -0, but in normal arithmetic, when we add two number or when we subtract two number, there is no concept of +0 and -0. So let us see, means how do we overcome this problem in 2's complement. So note this down very quickly, note this down and let me know. Noted? Okay, now the same numbers I have taken, I want you to find me what will be the equivalent number. So this is 2's complement representation, means I should have written sign magnitude representation. 2's complement sign magnitude representation of some number are given. Find the original number. Very quickly find me. Find the numbers. See if we are getting the same thing or not, or if there is some changes. See, look over here. So from here to here, as this is all in sign magnitude representation, 2's complement. So this corresponds to positive number, this corresponds to negative. So positive number, this is means very simple to write. So this is 0, this is 1 plus 1 plus 2 plus 3. What about this one? This is negative number. Okay, this is negative number 1 0 0. Now if you take, means this is what, if you take 1's complement, because this is in 2's complement number, okay, and this is negative number, so if I want to find the original number, what I need to do, I need to take the 2's complement of the given 2's complemented number. So that will be what, 1. And even if you go by the shortcut, what you can see that the 2's complement of this number will be 100 only, okay. And even if you don't agree, you can use this method. First calculate what, 1's complement, to this add 1. So if you add 1, this will be 0, this will be 0. And don't ever put a 1 over here and make this 0 and tell sir this is 0. No, this is actually a special case of 2's complement. Whenever you have number like this in sign magnitude representation, okay, in sign magnitude representation. So for this you count the number of zeros, so here you have 1, so this is minus 2 to the power 1, this is what, minus 2 to the power 2, this will be minus 2 to the power 3, and this will be minus 2 to the power 4. So this is your special case of sign magnitude representation in 2's complement, okay, in 2's complement. So this number will now correspond to minus 4, this number will correspond to minus 3, minus 2, and this will correspond to minus 1, okay, minus 1. You can calculate the 1's complement like over here, 101. So this is sign bit, search for the first one, you can see directly you are getting 1 over here, and then you need to complement all the number, means all the bits, so this will be 1, and sign bit you don't need to do anything, so this is what, this is minus 3, so that is what I have written, this will be minus 2, minus 1. Now you can see that in your 2's complement for 0 I have only just one single representation. So this is one more usefulness of 2's complement, due to which we prefer 2's complement over 1's complement. So using 3-bit, the range of number that I can represent using 2's complement, it is from minus 4 to plus 3. Okay, now if I want to write in generalized way, so that will be what, so this is using 3-bit. Now if I take 4-bit, so for 4-bit it will be what, from minus 8 to plus 7. Similarly if I write for n-bit, so for n-bit it will be minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. Okay, so tell me, any doubt in this? Did you understand why we usually use 2's complement now? Tell me yes or no. Did we understand both the points why we are using 2's complement? Why not 1's complement is used in our modern day computer and calculator? Due to all these things, because 0 has only a single representation. It means plus 0 and minus 0, there is no significance in arithmetic. Okay, is this clear? Tell me. Yes or no? Any doubts up to this point? Anyone? Quickly let me know. So if you have understood, then kindly solve this question. We have few questions over here. So these are very good questions, and then we have this concept of overflow. Then this chapter will be over.
Sir, so what's the
Pardon?
last one, sir? So last slide,
Last?
sir. Slide,
This one?
sir. Yes, sir.
So solve it quickly. Okay, solve this question. Solve this question very quickly. Tell me quickly what will be the answer for this question. C. Good. PU Shubham, what happened? So look here. This three number 11001, 1001 and 111001 correspond to the 2's complement representation of which one of the following set? Now if you look at the numbers, means look at the options, so what you can see basically that these are your sign magnitude representation. Why? Because you can see negative numbers. So don't think that this is your normal 2's complement number. These are represented in your sign magnitude representation due to the fact you can see that -6, -7, -25, -9, -57 it is given. So now if this is in sign magnitude representation, you should be knowing that all the leftmost bit are your sign bit. So in all the three numbers you can see that it is 1. So all the three numbers are negative. So either it will be option B, option C, option D. We need to check now. So these are in 2's complement. So if I want to get the original number, what I need to do, I need to take 2's complement once again. So keep this 1 intact, keep your sign bit intact and calculate the 2's complement. So if you start searching from your rightmost bit, you can see 1 is appearing first in the first bit only. So write this like 1 and then the remaining magnitude bit you need to complement one by one. So this will be 1 1 0 and this is your sign bit. So leave it like this. The next number if you see, so again 1 you are encountering at the first point only. So 1 and the remaining bit you need to complement and keep the sign bit intact. Over here also you are seeing 1. The remaining magnitude bit you need to complement. So this will be 1 1 0 0 1. So this corresponds to what? This corresponds to -7. Even this corresponds to -7 and even this corresponds to -7. So option C is your correct. And we know what? That -7 is represented like this in your 2's complement. So this is your sign bit. I have already told you if you copy the sign bit, your number won't be getting affected. Like this is your sign bit, so copy it down. So even this number corresponds to -7, but only the number of bits have increased. So that is 0, 1, 2, 3, 4, 5, 6, 7. So this is a 7-bit representation of -7 in 2's complement representation. Okay. So here also you can see only the sign bit has been done what? It has been copied further in your left hand side. Is this concept clear? So this was a very good question. Now tell me what will be the answer for this question. Just look and tell me the answer. No need for solving. Quickly. See. Good. So here what is given? A number in 4-bit 2's complement representation is this. This number when stored using 8-bit will be. So here they haven't mentioned that whether this will be your sign magnitude or what. If nothing is said, just take it sign magnitude representation. Okay. If nothing is said whether the 2's complement is a normal 2's complement or a sign magnitude representation. So by default, you need to take sign magnitude representation. Okay, by default take sign magnitude representation. So this is x3, x2, x1, x0. So just copy the sign bit. So that will be x3, x3, x3. So this is your 1, 2, 3, 4, 5, 6, 7. Okay, so one more x3. So this is your 8-bit representation of the number. So that is option C. Any doubts in this? Okay, fine. So now solve this question. Okay, this you can take it as homework. This is normal subtraction. You can solve it, and I know, means I am promising you guys every day that I will share the slides with you. Today I am going to do it definitely. Okay, today I will do it. So today I will make this drive and I will share it with you guys so you can get the slides from there. Okay, so this question I want you people to solve. So how are you going to solve? Tell me. So what answer? Answer. What are we getting? 3 or 2. How can you get 3 or 2? Piyush, care karo. Solve it once again. How can you get 3 or 2? Yes, it is wrong, obviously. If base is 3 or 2, the above equation, the given equation is invalid. Because in base 3, the numbers you will have is 0, 1, 2. And in base 2, you will have just what? 1 and means 0 and 1. Bhumika, no need for typing so much. You can just unmute and tell. So look here. Okay. Look here. So this is what? 135 base x plus 144 base x is equal to 323 base x. Now we know what? Assume 108. I tell you that this is in base 10. Base 10 means what? We have from 0 to 9 digits. So if I want to represent this number in your base form, so this will be what? 1 into 10 square. So this is what? This is your 100 place, tens place, unit place. So this will be what? 0 into 10 to the power 1 plus 8 into 10 to the power 0. So this will be 100 plus 0 plus 8. So this comes out to be 108. Similarly, why you are not sure? 6. Okay, let us see. Never ever say that you are not sure. Either don't live your life in the gray zone. Either it will be black or it will be white. Okay, everything. Either it will be black or it will be white. So look. Yes, I was telling about base. So similarly, here we have base x. So I can expand this equation like this. 1 into x square plus 3 into x to the power 1 plus 5x to the power 0 plus x square plus 4x plus 4 is equal to 3x square plus 2x plus 3. So now if I solve this, this will be, let me bring this x square over this side. So this will be x square and this is 3x 4 7x, 7 plus 2, so this will be minus 5x, and over here we have 5 plus 4, so that is 9, so minus 6 is equal to 0. Now you might be tempted to write x minus 2x minus 3. This is wrong, because if it is minus 2 minus 3, then this should have been plus 6, but it is, means in our case it is coming out to be minus 1, so that is why Piyush got 2 and 3. Okay, so Piyush, don't do mistake like this. So this will be what? This will be x minus 6 x plus 1, because minus 1 plus 6, if you add you will get minus 5, if you multiply you will get minus 6. Okay, so this is correct. So x equal to 6 and 1 minus 1, so minus 1, base cannot be negative, base needs to be positive, so 6 is correct, because if you get 6 you will have digit from 0 to 5, and you can see over here you have the digits from 0 to 5 only, nothing is exceeding 5, so 6 is correct. 6 is correct. Solve this one quickly. This question, Shubham, did you understand? Chalo, solve this question. Seven, seven, seven. Chalo, good. So everybody is getting 7 except Bhumika. Why? Bhumika, why are you not getting 7? So this is very simple. Let us assume the base of the number is x. So that is 2x plus 4 plus x plus 4 is equal to 4x plus 1. So this is what? This is 3x. So if you take it over here, so this will be x is equal to 7. So this is correct. So this question was once asked in ISRO. Okay, ISRO interview, that 2 4 plus 1 4 is equal to 41. Tell us what does this, what do we mean by this? So means it was kind of a puzzle. Okay, puzzle, it was a puzzle kind of question. So it was asked to one of my friend. Okay, so he said it's 7. Okay, so now this two questions are very, very good. I want you to solve this one by one. Chalo, very quickly. Very quickly. Then we have this concept of overflow. So solve this question. We will see the concept of overflow. Then I am going to leave you guys. Okay. Because once again this headache is starting. So that is why I was thinking to take rest today also. Quickly. So you guys, means let me pause the recording. Let me not take it. Okay. So now in this question, what we have, consider the equation with x and y as unknown. The number of possible solution is. So what will be the possible solution? So let us solve. So here base is 5. Here base is y. So this will be 1 into 5 square plus 2 into 5 plus 3 is equal to xy plus 8. So this will be 25 plus 10 plus 3 is equal to xy plus 8. So this will be 25, 35, 38. 8 means xy is equal to 30. So x and y needs to be equal to 30. So let us make the possibilities of x and y. X, y. Either x can be 1, y can be 30. Or x can be 2, y can be 15. X can be 3, y can be 10. X cannot be 4 because then y will not be a whole number. Here we need to have whole numbers only. So if it is 5, it will be 6. If it is 6, this will be 5. For x 7, 8, 9, there will be no combinations of whole number. For 10, this will be 3. For 11, 12, 13, 14, we don't have any combination. For 15, this will be 2. And if it is 30, this will be 1. Now we need to check which of them are valid. So look here, x is the base and y is a digit in this base y. So if y is 30, means if it is base 30, then x is a valid number, because if base 30, that means you will have your digits from 0 to 29 or whatever you will be representing in 29. Okay, so this is valid. For 15 also this is valid, or basically whatever, means what I want to say over here, that y should be greater than x, that's it. Okay, y should be greater than x, that's it. So look over here you can see what, that y is greater than x in this 4 condition. But if you select this, if you select y as 6, look what happens. If you select y as 6, then this 8 is invalid. So one more thing you should have is that y should be greater than 8. So this 2 condition needs to be simultaneously satisfied, and this is only satisfied in this 3 case. So that is why 3 is the correct answer, not 4, because if you take base as 6, so this 8 is invalid. Okay, so that is why base 3 means three possibilities you have for actually holding true this equation. Okay, any doubts? Shubham, Piyush? So Bhumika got the answer. That is very good. Now solve this question. Solve this question. This is also on the same pattern only. Same pattern. So what is the answer? Quickly tell me. Zero? How can this happen? Piyush is telling 7. Shubham is telling 0. Bhumika? What answer are you getting? Bhumika is also telling 7. Okay. So look, consider the equation this where x and y are unknown, the possible number of possible solutions is. Okay. What is the possible solution you have? So here you can see after solving this, I got this. So look over here. If y is 1 and x is 2. See, this cannot be the case. Why? If x is 2, so base over here, if it is 2, how is 4 and 3 a valid digit in this? So this case is invalid. Okay, this case is invalid. Or you can directly say that whenever x is greater than 4, okay, first case is what? When x is greater than 4, so that means all this case that you have over here, okay, x is greater than 4, so these are your valid case. But look over here, what you need to have, that y and 3, so y should be less than equal to 7. Why? Because here base is 8. If base is 8, then valid number can be from 0 to 7 only. So if it needs to be less than 7, y needs to be what? Sorry, here what I said, so this is not, I am very wrong. So x needs to be greater than 4. So these are the cases, because this is x greater than 4. So this will go on till infinity. And y needs to be less than equal to 7. So less than equal to 7 means all these cases, okay, because this is less than 7. So common cases you can see are what? From here to here. How many number of cases? 1, 2, 3, 4, 5, 6. So 6 number of cases. Why are you guys getting 7? Why 7? Why are you getting 7? Why are you getting 7? I am asking that. So Piyush and Bhumika. X equal to 4, y equal to 2. Yes, very good. Now x equal to 4 and y equal to 2. Okay, yes. So even this I have made mistake. Sorry. So x should be greater than 4. That means it should be x should be greater than equal to 5. I am very sorry. So even this case needs to be excluded. X should be greater than 4 means this case, and over here it should be less than 7. Very good. So common is only this much. So this is 1, 2, 3, 4, 5. So correct answer is 5, not 6. Okay. Yes, I myself have written x greater than 4 and then I included 4 also. Okay. Yeah, it is 5, not 7. So you guys have only taken either this one, okay, then only you will be getting 7 as your answer. If you take just this, then you will be getting 7. If you take along with this one also, then this will be what? This will be only 5 cases are possible. So always take care when you have such kind of question to get all the possible combination or all the possible conditions that we have. Even if you make a simple mistake like I did, I also considered 4 over here after writing x should be greater than 4, not equal to 4. Still I took 4 and you can see I got 6 as answer. Okay. So that is very wrong. 5 is the correct answer. Okay. So thank you. Who rectified my mistake? Piyush. Yeah. So thank you, Piyush. So next concept is what? Concept of overflow. So this is the most important concept. Okay, most important concept that we have in this. So very quickly, let us try to do what? Let us try to do all this calculation using 2's complement. Okay, let us do using 2's complement. So first, so how do we write plus 2 in 2's complement? It is very simple. Sorry, 0, 1, 0, and plus 3 is written as 0, 1, 1. How do we write minus 2? 1, and this will be 1, 0. Okay, this will be 1, 0. Why? Because if you take sign magnitude representation of minus 2, so that will be 1, 1, 0. So once again you need to take what? 1's complement. So this will be 1's complement. If you take 2's complement, so this will be 1, means you need to add 1 to this, so that will be 1, 1, 0. So that is what I have done. Now if you take 2's complement of minus 3, so that will be what? 1, 1, 0. So this is minus 3 in 2's complement. Okay. So I have written minus 3, minus 2, everything in 2's complement. Now simply I need to add this over here. So minus 3 plus 2. So minus 3 just now I wrote. So that is 1, 0, 1, and this plus 2 is what? 0, 1, 0. Okay, 0, 1, 0. Now let us add this. So if I add this, so 1 plus 0, that is 1, 0 plus 1, that is 1. Now this position, whatever carry I will be getting, I am writing this as C in at this position. So here you can see 0 plus 1 is 1, C in is equal to 0, and this 1 plus 0, this is again equal to 1, and over here what is the carry generated, I am writing it as C out. So C out is 0. Okay, C out is 0. C in is 0, even C out is 0. So did you understand what I am trying to say over here? The C in, C out. Did we understand what is the C in and C out? C out is the overall carry after this MSB position, and C in is the carry just one bit before MSB. Okay, C in is the carry just one bit before MSB. So this is your MSB. So just one bit before it, you can see 0, when you add 0, 1, so you get 1, carry will be 0. So this C in, I am writing it as just the carry of one bit before MSB. Okay. Now similarly, let us add this two number. Okay, before adding this two number, you can see the result we got. Okay, result we got, as no carry is generated, it will be negative number, and you can see even the sign bit is indicating so. Why? Because it is 1, so this is a negative number. So if I need to calculate the original number, so we need to take 2's complement of this number, so that will be what? That will be 1, and this will be 1, 0. So this, if you convert it, so this is what? This is minus 1, and this is quite true. If you do minus 3 plus 2, your result should be minus 1. Tell me if this is clear to you or not. See, this is very important concept. If you don't understand, it will be very difficult later on. Tell me, is this clear, all three of you? Okay. So now let me add minus 2 plus 3. So minus 2 in 2's complement, I have calculated, it is 1, 1, 0. So 1, 1, 0. Okay, 1, 1, 0. Now plus 3, what it will be? It will be 0, 1, 1. Add this 2. So this will be 1. 1 plus 1 is 0. Okay, 1 plus 1 is 0. This position is again seen. So you can see this will be 1 plus 1, 0, 0 plus 0 will be 0, and C out will be 1 because 1 plus 1 is 0, carry is 1, and again this 0 plus 0 is 0, carry out is 1 over here. Okay. So now you can see carry, when carry is generated, so this position is your C in and this is C out. So when carry generated, that means it is your positive number, and this is also shown by the sign bit which is coming out to be 0. So this number, if you want to calculate the original number, no need to take complement because this is positive number. So this comes out to be plus 1, and we also know that minus 2 plus 3, we always get plus 1. Now let us add 3 plus 2. So plus 3, it is 0, 1 1, and plus 2 is 0 1 0. So if I add these two numbers, so this will be 1 plus 0 is 1, 1 plus 1 0, carry is 1, see this is seen. So 1 plus 1, that is 0, and just a minute. Why am I getting this wrong? 1 plus 0 is 1, 1 plus 1, this is 0.
So that should be 2, right? Like 0 1 0.
Oh yes, yes, yes. So this is actually correct thing that I am getting, but what I was expecting, I will tell you it. So this is 0, this is also 0. So how I actually knew that the result I was getting is wrong, I will tell you. Okay. So this is 1 plus 0, this is 0, 1 plus 1 is 0, this is 1. So you can see C in is 1 over here, carry input is 1. So this will 1, and C out is what? It is equal to 0. Okay, C out is equal to 0. So now look at this number. Yes, tell me,
Hello.
any doubt? Yes.
Actually, the last bit is 1 here for 3 plus 2.
What last bit is 1? Yes, so?
No, this least significant bit is 1 in the result.
Okay, okay, yes. Okay. So look very carefully. You can see I added two positive number. So when I add two positive number, I should be getting a positive number. But look at the sign bit of the result. It is 1. So that is indicating that this number 101 in your sign magnitude representation in 2's complement, this is negative number. So if I calculate the original number, so that will be what? That will be your 1, and if you take 2's complement once again, so this will be 10. So this is minus 2. How is 3 plus 2 minus 2? So there is some wrong over here. We will see what. Now look over here. This is minus 3 minus 2. Minus 3 minus 2. So minus 3 minus 2, just now we have seen that this is what representation of minus 3 is 1, 1 0 1, and for minus 2 it is 1 1 0. Add this 2, so this will be 1 1, again 1 plus 1. So this over means over here we have what? We have seen 0. So 1 plus 1 is 0, carry out is 1. So this is C out, this is C in. Once again you can see I have added two negative numbers, but look at the sign bit of this resultant number, it is 0. This indicates that the resultant number is positive and the equivalent number is plus 3. So there is some wrong. Can you tell me actually what is happening in this two case? What is happening? What is happening in these two cases? Anyone want to take guess? So look here, I am representing this -3 and -2 using 3-bit 2's complement representation. So for n-bit 2's complement representation, the range of number that we have, it is from -4 to +3. Just now I have written for 3 bits where it is. So over here -4 to +3 you can see. So look at this place. So -3 plus 2, -3 plus 2. So the result is what? This is -1. Over here it is +1. Over here it is +5, and over here it is -5. So -1, this comes in this range. +1, this also comes in this range. But look at +5. +5, I cannot represent it using 3-bit 2's complement. It is out of the range of 3-bit 2's complement. So that is why I am getting wrong result. Even over here, -3, -2, I am getting -5. So -5 is also out of range because using 3-bit 2's complement, 3 bits 2's complement sign magnitude representation, I can represent a number from -5 to +3. So how will I be able to represent -5? So that is why I am getting erroneous results. Okay. So this condition is known as overflow. So what do we mean by overflow? That basically the resultant number that I am getting, it is actually out of range with the bits of number that I have represented. So this is what this condition is known as overflow. Now overflow condition happens whenever C in XOR C out is equal to 1. So when I was actually solving over here, I got C in and C out as both of them as 1. So if I XORed it, it would be 0. So that is why I knew that the answer over here was wrong. So overflow condition happens whenever C in XOR C out is 1, and for overflow not happening, C in XOR C out is 0. In this case, overflow does not happen. But whenever in this case, overflow will happen. Tell me if you have understood this or not. Understood this? Understood, yes or no? Very quickly tell me. Any doubts in this? One more thing I will tell you.
So
Yes, tell me.
that 3 plus 2, the complement of the result will be 1, 1, 1. No? So
What? 1, 1, 1?
yes, sir.
Yes, it will be 1, 1, 1, 1, 1, 1. Yes, sorry. I told you guys once again I am having headache. Okay, so my thought is not that clear. So this is 1, 1, 1. Yes. So this will be -3 then. Okay, -3. So yes, this is okay. -3 and +3. So now tell me, is this clear? C in and C out. So this is the condition for overflow. Whenever overflow happens, this C in XOR C out, it will be equal to 1. Whenever C in XOR C out is equal to 0, that means overflow does not happen. Now one more thing, look. Whenever we add two positive numbers, okay, look at the sign bit. When you add two positive numbers, so let me denote the sign bit of this number by X and this by Y and this by Z. So 0 will be represented as X complement, 0 will be represented as Y complement, and this is Z. So condition for, okay, so let me make one table. So what I am telling, I have two numbers A, B, So when I add A, means the sign bit for A is X and sign bit for B is Y, and the resultant of this two is C, and the sign bit for that is Z. Okay. So now look very carefully. X, listen very carefully. What I told, this is the sign bit of the number A, Y is the sign bit of number B, and Z is the sign bit of number C. So what all combinations can X, Y, Z have? So it can be either 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the all 8 combinations that X, Y, Z can have. Now look very carefully. 0 corresponds that X0 means what? This is your sign bit. So A positive, B positive. So when you add two positive number, your resultant is positive number. So that means overflow has not occurred. So not occurring of overflow, I am denoting it using 0. I am denoting it using 0. Look over here. Overflow not occurring is 0. Now look at this place. Sign bit of X is 0. Sign bit of sign bit of A is 0. Sign bit of B is 0. But sign bit of the resultant is 1. So X0 means what? That A is a positive number. Y0 means what? B is positive number. But Z is equal to 1 means what? C is a negative number. How can you get such a number that when you add two positive number, you are getting a negative number? So that means overflow has happened over here. So I will be writing it as 1. Now look at this place. X0, Y1, Z0 means X is a positive number, Y is a negative number, and Z is a positive number. This can obviously happen if X is greater than Y. In this case, overflow will never happen. Okay. You take any number in between these two. Take any number in between -4 and +3. You try to add and make it out of range. Means I am telling one number should be negative and another number should be positive. You take any combination and try to take this number out of your range. So you might be thinking, let us take -4 and +1. So this is -3. This is in the range. If you want to take -4 + 0, so this is -4. This is in the range once again. So you will never have overflow condition when you add one negative, one positive, or one positive, one negative. You will never have overflow condition. Overflow condition is most likely to happen when you add two positive number or when you add two negative numbers. Like there is a possibility if you add two positive number, let us assume +1 and +2. So you are getting +3. So this is in the range. This is in the range. Okay, for 3-bit. Let me assume if you add +2 and +2, so that is +4. So +4 is out of range. So whenever you add two similar numbers, there is a possibility of overflow. Okay, so that is what I am trying to explain. Over here also, you will not be having overflow because here also you have dissimilar numbers. So dissimilar. Look over here in this case. In this case, you look. X is 1, Y is 1. So this indicates that A is negative, B is negative, but the resultant is a positive number. So here also overflow is happening. Okay, overflow is happening. But look at this case. X negative, Y negative, and Z is negative. So this is a valid case. If you add two negative number, the resultant is negative. So this indicates that overflow has not happened. So this is 0. So if we want to write this two case, so this will be what? X complement, Y complement, Z plus this condition if I want to write, so this will be x, y, z complement. So this is actually the condition for overflow, where x indicates your sign bit of the first number, y indicates the sign bit of the second number, and z indicates the sign bit of the resultant number. Okay, so if this function comes out to be 1, then you can say overflow has happened. Or one other way of saying is what? When C in XOR C out is equal to 1, you are going to say overflow has happened. Okay, any doubts? Did you understand the concept? Tell me, all of you. So if you have understood, I want you to solve this question. So this is direct, okay, whatever we have done just now, so you can see. So you might be telling me the answer that option C is correct. Okay, option C is correct. Okay, this one tell me. So look over here. This was in 1998. This is in 2017. Okay, so after 19 years, the concept is once again repeated, but with a little twist. Okay, with a little twist over here. Can anyone tell me what will be the answer? C. What about others? Piyush, Bhumika? Arey, very good, yaar. Everyone got correct answer. So this is good. So what is said, when a 2-bit 8 numbers from A7 to A0 and B7 to B0 in 2's complement representation with A0 and B0 least significant are added using ripple carry adder, the sum bit obtained are S7 to S0 and the carry bits are C7 to C0, and overflow is said to have occurred if. So they are asking when will the overflow occur. So if they had mentioned a C out over here, so you could have said if C7 plus C out, C7 XOR C out is equal to 1, then overflow has happened. Or you can say what? If A7 is indicating a positive, B7 is means if A7 is equal to 1, A7 is the sign bit of A and B7 is equal to 1. So both are negative numbers, means A is negative and B is also negative. Okay. If we get S7 as positive, means 0, means S is positive, then we will be saying what? That your overflow has happened. So if I want to write this in Boolean expression, this will be A7, B7, S7 complement. Or one more case is what? If A7 is equal to 0, B7 is equal to 0 and S7 is equal to 1. If this is equal to 1, then again what I will be saying, that here you can see that A is positive, B is positive, but the resultant of the addition of this two number is negative. So that means overflow has happened in this place. So if I want to write this in Boolean expression, so this will be A7 complement, B7 complement, S7. If either of the function is true, true means what? If it is 1, so that means overflow has happened. So this is option C. This is option C. So you can see option C is the correct answer. So you can see that concept is repeated with a little twist. So that is why I will always say, please buy previous year question papers and solve them carefully. Okay, solve them very carefully. So all the three branches, EC, electrical, IN. If you are from any one of the branch, either from EC or electrical or IN, buy all the three and start solving question. And if you are from CS, it's okay. You can ask any one of your friend to send you the photos of this digital electronics from these three streams. Okay. So Piyush, you can ask others. So don't buy this previous year questions now, because questions of 2022, it will not be still there. Okay, so just wait for 1 or 2 months. Okay, after the publication of the result, so you will get even the 2022 question papers also. Okay, is this clear? So with this we end the chapter number 1. Okay, so from next class we are going to start combinational circuit. But before that, we have few questions over here. So I am posting these questions as homework. Okay. So these are your homework questions.